Assalamualaikum warahmatullahi wabarakatuh. How are you everybody? I hope you have a good day today. Before we start, let me introduce myself. My name is Natasya anggraini. My study ID is 1813023017 as presenter 11. The title of my presentation is Review of Chemistry Articles. The title of the article they are used is Effect of the Fake Chemistry and Kinetic Behavior on Electrochemical Properties for Hydrothermal Synthesis of Lithium Iron Phosphate C cathode material. In the presentation, I squared three sections. The first is structure review, second content review, and the last my conclusion of the article. Okay, the first section is structure review. First is title. Title has a purpose to clearly describe content of the article. Title of the article is Effect of the Fake Chemistry and Kinetic Behavior on Electrochemical Properties for Hydrothermal Synthesis of Lithium Iron Phosphate C cathode materials. Next, authors. Authors has a purpose to insert recognition for the writers. The authors of the article is Wenzheng Zhua, Sungying Lia, Zhengfang Wena, Jinpeng Xua, and friends. Next, keyword. Keyword has a purpose to insert the articles is correctly identified in abstracting and indexing service. The keyword of the article is lithium iron phosphate, hydrothermal synthesis method, HA value, cation mixing, and lithium ion diffusion. Okay, next, abstract. Abstract has a purpose to be describe what was done. You can see the abstract in the articles. Next, introduction. Introduction has a purpose to explain the problem from the experiment, and then you can see the introduction of the articles. Next, experiment or method. Method has a purpose to explain how the data were collected, and then you can see the method of the articles. Next is result. Result has a purpose to be describe what was discovered, and then you can see the result in the articles. Next is discussion. Discussion has a purpose to be discuss the implication of the findings of the article. Next is acknowledgement. Acknowledgement has a purpose to researchers who help in the research are recognized, and then references. References has a purpose to insert previously published work is recognized. Okay, next section. The second section is content review. The content review, I have 4 questions. First is purpose. Second, why does the author use the hydrothermal method in his research? Third, how is the result? And last, conclusion. The first is purpose. The principal aim of this study is to understand the mechanism of nucleation and crystal growth, chemical default, and kinetic behavior in order to optimize the properties of lithium iron phosphate. In addition, determine the effect of pH of the precursor solution and reaction time on the formation and electrochemical performance of the lithium iron phosphate cathode material was investigated. Okay, next question. Why does the author use the hydrothermal method in his research? The author used the hydrothermal synthesis method because hydrothermal synthesis is one of the most effective approaches due to the advantages such as a simple synthesis process, the preparation of fine particles, and low energy utilization result from mild operation temperature. And then next question, how is the result? Okay, the next is how is the result? You can see the picture number one. The picture number one is result of XRD parents of lithium iron phosphate prepared at different pH value. X-ray diffraction of lithium iron phosphate prepared at pH is 4, so an impurely based Fa3PO42, which is apparent from the extra diffraction line observed around 15 to theta, and is not so obvious at high diffraction angles. When the pH is 8, 9, and 10, only pure lithium iron phosphate C phase, which can be indexed to the orthorhombic structure with a space group of PNMA, is observed. In the range of pH value from 8 to 10, XRD parents show the greater the pH, the stronger the intensity, and the sharper in the peak. Thus, the higher the crystallinity, then the pH is greater than 10. Other two impurely passes Fa4PO42 and Fa4 plus 3 PO43OH3 dot 12 H2O exists. This picture number 2. The further investigate the presence of Fa on LECTs for the single phase of lithium iron phosphate. The FTER spectral analysis for pure lithium iron phosphate prepared at pH 8, 9, 10 were also conducted. The FTER spectra of pH 8, 9, 10 samples are presented in picture number 2. It can be seen that only the absorption band in the range 9,550 until 1,000 cm min 1 undergo a shift along with the pH value, and the asymmetric stretching V3 model, V2 model, and V4 model remain almost unchanged in position. This shift is ascribed to the anti-side defects. The presence of Fa on LECTs could change the first contents of phosphate groups. The B, enhancing the symmetric expecting V1 model frequency. The result from the FCER spectra show the degree of Fa cities for pH 8-9 sample is smaller than that of pH 10 sample. Next is picture number 3. Also in picture number 3, lithium iron phosphate C prepared at different pH value has different morphology, indicating at the pH value of the solution play vital roles on crystal structure and crystal morphologies. As the increasing of pH value, the deposition rate of configurational ions gets higher and higher. Then the deposition rate of configurational ions is higher than the dissolution rate. The L phosphate base is easy to form because of quick nucleation rate. Besides the pH value and reduction agents, other parameters such as hydrothermal temperature and reaction time are also the key parameters in the synthesis. Next is picture number 4. The dot line, which is good for ice in picture number 4, tells us the BAT surface area increases as a trend with the increase of pH value. Smaller particle size is of advantage to the Le positive ion migration. However, excessive surface area is harmful to electrochemical properties due to parasitic reaction between electrode material and electrolyte. Thus, 3 is an appropriate particle size that is beneficial to electrochemical properties. Next, picture number 5. The picture number 5 shows the charge or discharge profile at 0.2 C in the first cycle for the lithium iron phosphate C prepared at different pH values. The result in picture number 5 show that firstly, the discharge capacity of the final product increased with the increase of pH value. Then discharge with the further increase of pH. The discharge capacity at 0.2 C in the first cycle are listed in table 3. This is table 3 in the picture number 7. The discharge plates versus lithium positive per lithium for lithium iron phosphate C prepared at pH 10 is higher, indicating best performance. Okay, next picture number 6. The picture number 6 show the discharge capacity of lithium iron phosphate C prepared at different pH value during continuous crying at different discharge rate. When the current density refers back to the original rate of 0.2 C, all the sample can relate the initial discharge capacity. Okay, next picture number 8. Picture number 8 is pairs of typical reversible redox peak are observed for all the sample in the CVAs, which are corresponding to the extraction or insertion of lithium positive and the charge or discharge reaction of the Fa2 positive or Fa3 positive redox couple. The narrowly symmetrical redox peaks suggest the good extraction or insertion diversibility of the produced lithium iron phosphate by hydrothermal synthesis. The CV performance is consistent with the result that the lithium iron phosphate cathode prepared at pH 10 has high capacity and better rate performance than those of the other during charge or discharge measurements. The picture number 9 shows the Nyquist plot of lithium iron phosphate prepared at different pH value. All the electrodes exhibit a typical AEC of GEM against GRA for lithium iron phosphate electrochemical cells, which consist of shapes in the high frequency region. As the depressed semi-cycle in the intermediate frequency region and a strike line in the low frequency range. The depressed semi-cycle in the intermediate frequency region for lithium iron phosphate C prepared at pH 10 in the smallest, indicating the lowest change transfer resistance and has the highest exchange currents. Next, picture number 10. For the table 4 is the kinetic parameter the referred for the simulation to Nyquist plot. You can see the table. Rs is the ohmic resistance of the electrolyte, and RCT is the charge transfer resistance, and then LDA is the lithium ion diffusion. Next, picture number 11. Picture number 11 shows the XRD parents of lithium iron phosphate C obtained at different reaction times at a fixed pH value of 10 respectively. In the impurely phase Fa3PO42 and Le3PO4 phase exit in the obtained lithium iron phosphate C, then the reaction duration is 5 hours. As reaction time results 10 hours or higher, only pure lithium iron phosphate C phase is observed. Okay, next, picture number 12. Picture number 12, the optimum reaction time for preparation of lithium iron phosphate C in this study is at least 15 hours. When the reaction time is higher than 15 hours, the charge or discharge capacity so little charge shown in picture number 12. Next, the last is conclusion. The conclusion author is lithium iron phosphate cathode material for lithium-ion batteries were synthesized successfully by hydrothermal synthesis method. The XRD results show that at low pH, the phenol produced contain impurely phase. As pH value increasing, the impurely phase disappears gradually and the XRD peaks of lithium iron phosphate become higher and sharper. With the further increase of the pH value, other impurely phases appear. The stability produced principle is reasonable to illustrate the chemical composition of the phenol produced in the hydrothermal process. A full Rietveld refinement of XRD parents and further transport in infrared spectra result of lithium iron phosphate C prepared at pH 8-9-10 suggests anticipate the fake in the intrinsic characteristic of lithium iron phosphate synthesis by hydrothermal process. The pH 10 sample has a appropriately completely resolved between Le or Fa cation missing and the lithium ion diffusion path like result in a good lithium ion diffusion kinetic. Therefore, the discharge capacity at 0.2 C in the first cycle, the rate performance, the CV and the AAC performance are up to optimum for pH 10 sample. The mechanism of nucleation and crystal growth, the difference chemistry and the kinetic behavior are essential for optimize the properties of lithium iron phosphate. The optimal reaction time is at least 15 Hz for the hydrothermal synthesis of pH 10 sample in the study. Okay, next the last section is my conclusion. My conclusion is lithium iron phosphate cathode material for lithium-ion batteries is expected to alleviate the energy crisis problem in the next few years. The hydrothermal synthesis method is used in this research because of the simple synthesis process, the preparation of fine particles, and the low energy utilization due to the low operating temperature. Precursor pH has very important effect in the synthesis of pure lithium iron phosphate morphology and the formation of the final impurities of the product. This all my review for the articles. Thanks for your attention. If any question, don't decide and comment on the feedback discussion. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.